Today we're going to talk about exponential differentiation rules, and we have two concepts here, and we're going to be talking about the two other concepts that we're going to mention in a minute. But anyways, before we get into exponential differentiation rules, when we're utilizing differentiation rules within exponents and logarithms or natural logs, we got to understand that these are applications of the chain rule. So it's essentially literally utilizing chain rule, and we'll emphasize that. So anyways, basic exponential rule, we know that if y equals e to the power of x, then the derivative of e to the power of x is literally e to the power of x, because the derivative of e to the power of x is itself, and we know that is an ingrained rule in calculus. Now, exponential with an inner function chain rule, basically, like I mentioned before, we were talking about how this is an application of the chain rule. So in this case, we know that y equals e to the power of u of x, then the derivative of e to the power of u of x multiplies into u prime of x. So in this case, we have an example problem right here. So y equals e to the power of 3x squared, which gets us y prime equals e to the power of 3x squared times 6x. And how we got 6x, I'll emphasize that. So we use power rule right here. I'm just going to write power rule right there. And basically, we see 3x squared. So in power rule, we know our formula is a x, my bad, a nx and n minus 1 as the exponent. So remember, that is our power rule. And we know that 3x squared, utilizing the power rule, we know that our exponent of 2 gets subtracted by 1, and we multiply the 3x by 2. So we would literally get 3x times 2, and we have an exponent of 1. So yeah, so then we get 6x, and that is how we get our 6x right here when we're finding our u prime. And therefore, y prime equals e to the power of 3x squared multiplied by 6x.